Hello, dear learners. When you are attending a maths lesson with me, please get ready with a book, pen, and a calculator. Today, we are going to discuss the grade 12 chapter probability. Grade 10 and 11 probability is going to be revised when we do exam questions. But before we start with the grade 12 probability, let me just remind you about some special terms that we use here, such as events, outcomes, and etc. So let's take the famous example of throwing a die or tossing a coin. Here now I'm going to take the example of tossing a coin. As you all know, when you toss a coin, you get two different outcomes. That means you get a head or a tail. That is, if you toss a coin once in the first toss, you get a head or tail. But if you toss it again, suppose you got a head in the first toss, still in the second toss, you're still going to get a head or tail. Even if you got a tail in the first toss, still you can get a head or tail in the second toss. That means after tossing 2 times, you may get 2 heads. That means head in the first toss, head in the second toss, head in the first toss, tail in the second toss, tail in the first toss, head in the second toss, tail in the first toss, and tail in the second toss. So this getting a head is an event. Tossing a coin is an experiment. Now, how many outcomes did we get after tossing the coin twice? We got 1, 2, 3, 4 outcomes. After tossing the coin 2 times, we got 1, 2, 3, 4 outcomes. So these are the outcomes. Maybe now you remember what are these outcomes, events, and all that. Let's go to the formula for finding the probability of an event. Probability of any event is equal to the number of outcomes of the event divided by total number of possible outcomes. For example, let's take the tossing of the coin once more. As I told you, getting a head is an event. So how do we calculate the probability of getting a head? So according to the formula, probability of an event is number of outcomes of the event. How many heads do you get when you toss a coin? You only get one head. There is only a possibility of getting one head. What are the total number of possible outcomes? When you toss a coin, you only 2 outcomes, which can be head or tail. So you have 2 possible outcomes. So that is a total number of possible outcomes. So the probability of getting a head is 1 over 2. Okay, that's how we use the formula. Now in this chapter, in this grade 12 probability chapter, we will study techniques used to calculate the number of outcomes in different scenarios, because the finding the number of outcomes is important in finding the probability of an event. So first we are going to learn how to find the number of outcomes in different situations. In grade 11, we used tree diagrams to find the different possible outcomes. That is what I was showing you just now. We used the tree diagram here to find the number of outcomes in when tossing a coin twice. We had 1, 2, 3, 4 outcomes. So if we are have different outcomes, not just 2, if you have 10 outcomes, and then you do that experiment once more, you get another 15 outcomes. In those cases, finding the total number of outcomes is difficult. You cannot draw the tree diagram to find the total number of, it's not easy. So that is when we need some other methods. That's when the fundamental counting principle is in use. That is what we are learning here now, how to use the fundamental counting principle to find the total number of outcomes. The fundamental counting principle is a rule used to count the total number of possible outcomes in a situation. It states that if there are n ways of doing something and m ways of doing another thing after that, then there are n times m ways to perform both these actions. Let us take the same example of tossing the coin. In the first toss, you had two outcomes. Then in the second toss, you still had two. If you toss the coin for the second time, you're still going to get only head or tail. So only two different outcomes. So the total number of outcomes after performing two times the tossing of the coin is 4. We have already seen that. We already saw the outcomes here. They were 4 outcomes after the first toss, and the second toss you had 1, 2, 3, 4. So that one is can be without even drawing a tree diagram. You can find it using the fundamental counting principle like this: 2 times 2 equal to 4, which is useful when there are many outcomes in one situation. Let's see another example in real life. In a real life problem, let's say this example. 1. A boy has 4 t-shirts and 3 pairs of pants. Find the total number of possible outfits the boy has. Okay, so he has 4 t-shirts and 3 pairs of pants. So imagine it's you having 4 t-shirts and 3 pairs of pants. How many ways you can style your dressing in every day? Okay, so you may say you have you can take this yellow t-shirt with the blue pant, then your red t-shirt with the blue pant, then your white t-shirt with your blue pant, or your black t-shirt with your blue. That is one way of styling. Again, the same 4 different t-shirts you can style with another pair of pants. So like that, how many ways you can style all your dresses? So the total number of outfits with the boy are 4 times 3. So actually you can style 12 different ways with the 4 t-shirts and 3 pair of pants. So this is where we are using the fundamental principle, counting principle, that is 4, one thing 4 times, another thing 3 times. So the total number of outfits is 4 times 3, 12. Now, the above example shows how the fundamental counting principle is applied. Now, the problem we face in exams involve arranging digits of numbers, letters of words, or digits or letters in codes or passwords. In these cases, the digits or letters may repeat, and in other situations, they may not repeat. So now the situation is whether there is repetition or no repetition. So these you may have noticed in exam papers you have questions like that. Let's take one example in that way. Number 1, how many 5-digit codes using the digits 0 to 9 are possible? So we are going to find how many ways you can make a 5-digit code. That's what we are going to check. So when you have such a situation, always take how many positions do you have to fill. Here it's a 5-digit code. How do you fill that 5 positions for the 5-digit? 1, 2, 3, 4, 5. So here you can have any digit from 0 to 9, another digit here from 0 to 9, another digit here from 0 to 9, from 0 to, so like that. So you can use any of the digit from 0 to 9. But how many digits are there from 0 to 9? There are 10 digits. 10 digits from 0 to 9. There are 10 digits. So out of the 10 digits, how do we use them in the first position? Which one can be in the, it can be any. We look at the first question. How many 5-digit codes using the 0 to 9 are possible if the digits may be repeated? That means, suppose you use one digit here. Let's say 2. You can use 2 again here. That is the meaning of digits may be repeated. That means the code that you are making can be like this: 2, 2, 2, 3, 3. It's a 5-digit, but the digits are also repeated. Do you see? That is an example of a 5-digit code where the digits are repeated. That's an example. So for the first position, you can use any of the 10 digit here. So how many possibilities are there? That is what we are going to write here. You can have any of the 10. That's how you fill in the first position. Second position, again, how many possibilities do you have? How many choices do you have here for the second position now? You still have all the 10 digits, and whatever you used here can be repeated. So how many possibilities there? There are still 10 choices to make. What about the third position? You can repeat, so you still have 10 choices to make in the third position. Fourth position, again you still have 10 choices to make. Fifth position also you have 10 choices to make. That means the answer to example 1 first part is 10 times, because the fundamental counting principle says you multiply. 10 times 10 times 10 times 10. So you can just say this as 10 to the power 5, or you write the final answer using the calculator. So final answer, because it's 10, it's easy to write. You write the 5 zeros there. Okay, that is 10 to the power 5. So this many codes are possible if the digits can be repeated. That is answer. Now number 2. If the digits may not be repeated, what do you do if the digits may not be repeated? Digits may not be repeated means, now you still, let me consider the positions again. This is the easy way for you also to understand the situation. You consider again the 5 positions and check how do you fill in the first position. How many digits do you have? You still have all the 10 digits available. Okay, how do we fill in the first position if the digits may not be repeated? So you didn't start filling the positions. So first position, you still have all the 10 digits available. We didn't take anything yet. So first position, you still have all the 10 available. Second position, how many choices do you have? You cannot repeat the digit you used. That means you only have 9 choices left because you cannot repeat. What about the third position? You only have 8 choices to make because you cannot repeat. You cannot use the 2 that you already used in the first and second position. So now for the fourth position, you are only left with the 7 choices to make. Then in the last one, you are only left with the 6 choices to make. So the answer to example 1, 2 is answer. The answer here is 10 times 9 times, 8 times, 7 times. Use the calculator to get the answer. Okay, the answer is 3240. Okay, let's see another example now. How many ways can the letters of the word Edgar's be arranged if letters may not be repeated? That's the question. No other options now. So you have the word Edgar's. How many ways can you arrange so that the letters may not and the letters cannot be repeated? So how many letters are here in the word Edgar's? 1, 2, 3, 4, 5, 6. 6 letters. So that means here you take 6 positions. 1, 2, 3, 4, 5, 6 positions. How many choices do you have for the first positions? There are 6 letters. So you have 6 letters available to fill it. 6 letters are available. 6 letters are. So in the first position, you can have any of the 6 letters. But the letters may not be repeated. So how many letters are available for the second position? Only 5. How many letters are available for the next position? Only 4. Then comes 3. Then only 2. Then only 1 is available because we cannot repeat. So actually the answer here is 6 times, 5 times, 4 times, 3 times, 2 times, 1. That is answer. So in the calculator, you can put all this like this, but there is another button in the calculator where you can use when you have such situations come. That means when you have 6 times, 5 times, 4 times, 3 times, 2 times 1, that is called 6 factorial. We read it as 6 factorial. It's called a factorial notation. Use the factorial button in the calculator. Did you see the factorial button in the calculator? You must use the factorial button in the calculator. So when you put 6 factorial, you are already getting the answer. The answer will be 720. So here our answer here is going to be 720. Okay. Now, so that one you check in your calculator how we use it there. Now, a 3-digit code is made up of the numbers 4, 7 or 9. How many different codes are possible if the codes are repeated and if the each digit is used only once? It's also an examination question. Let's see how we do this. So first one, 1.1.1. This is supposed to be 1.1.2. Okay. Now, first you look at the situation here. A 3-digit code. So that means we have a, okay, let me write it. I will write the answer there. We have 3 positions to fill in. What are the numbers used for the 3 positions? 4, 7 or 9 only. So you only have 3 digits to make the 3-digit code. Only 3 digits, 4, 7, not from 0 to 9 this time. Only 3 digits. So in the first position, how many choices do you have? Can the chords be repeated? Yes. In the first 1.1.1, the question says the chords are repeated. That means how many choices do you have in the first position? 3. It can be repeated. So if you use 4 here, you can use 4 in the second position also in the third position. It can be repeated. So how many choices do you have for the second position also? 3. How many choices for the third position? 3. So our answer in 1.1.1 is 3 times 3 times 3, which is 27. Okay, that's how we answer first one. Now 1.1.2, each digit is used only once. What does it mean? That means digits may not be repeated. So we still have all the 3 digits, but for the first position we can use any of the 3 digits, but they can only be used once. So second position, how many choices do we have this time? Only 2. Third position, you only have a 1 choice to make. So here the answer is 3 times 2 times 1, which is called the 3 factorial. That is called 3 factorial, which is 6. That is answer. So for today, I think this is enough. We will see the arrangements with the restrictions in the next lesson. That will be part 2 of probability. But you can ask your questions in the comment box. We will have a question and answer session by the end of this chapter, where I can answer all your questions that you write in the comment box. Thank you very much.